You are welcome once again. Today we are also focusing on integrals with initial conditions. The constant of integration C may be of interest in some applications right here. It may be of interest in some applications in such a way that we may specify, or one may specify, a point that is a solution of the antiderivative. You know that function that you get when after doing the indefinite integral, maybe kx plus c is more or less a general solution, right? A general solution to the system of the system is the general solution of which this one can be kx plus 1, kx plus 2, kx plus 3, right? So basically, in such cases, one may specify a point that is a solution to that of this antiderivative that you found, and therefore this will allow us to solve for the value of what? C. And before we can get to solve for the value of C, we need some further information to do that. And therefore, these points that will be given to us, those points or those information that will be given to us to help us find that of the value of C is what we call the initial conditions. Is what we call the initial conditions. So with that, those further information, we will not be able to find the value of C, and therefore our solution will remain a general solution. So let's go ahead and see something here. Let's find a function. For example, let's work with this example. Example 1. Let's find a function. Find a function f such that f prime of x equal to 2x plus 3 and f of 1 equal to negative 2. So looking at this question, they said find the function f such that f prime of x equal to 2x plus 3. So this function that they are asking you to find, they said find it from this derivative, right? This derivative, they say find this f from it. This means that they are asking you for an integration, right? They're asking for integration. It's not always that they will bring this sign or find the integral or this. You must understand how questions are being asked, how the various keywords that they use in asking questions and many more. So find the function of such that this f prime of x is equal to 2x plus 3. So this means that what function was there before it was what differentiated to get f prime of x. This is what you need to think of. So because of that, this is what we are having. So you just have to write your solution. And remember that they have given us an initial condition, which is what f1 equal to negative 2. What this initial condition means is that this f here, or f of x here, is equal to, when we are bringing it down to the basic level, we can say it represents what? Y, right? And therefore f of x equal to negative 2 means that x value is equal to what? 1. So I can say that they have given me my initial condition of which x is 1 and y is what, negative 2. So in doing this, let's find our let's find our integration. So this is an integral of f prime of x is equal to our integral of 2x plus 3. Right, and therefore in doing this we are going to get f of x is equal to 2x squared over 2 plus 3x, and in this way this will cancel this. We are going to get x squared plus 3x. So in getting this, remember that this is equal to f of x. Remember, you don't have to forget our c plus c. So this is our general solution. So this general solution that we have now, we don't have our c, but remember that the question has given us f of negative 1 to be, or f of 1 yet, f of 1 to be equal to negative 2, which means that f of x equal to negative 2, and therefore our x is equal to what, 1. And based on that, I wrote a point that 1 and negative 2. So, which means that our y can represent what, f of x, when we bring it down to a basic level. And therefore, this can help us find the value of c. So at f of x, the value is negative 2, which is equal to x squared, right? So what is x? X is 1. 1 squared plus 3, 1, and then plus c. And therefore, negative 2 equal to 1 plus 3 plus c. And therefore, c equal to negative 2 minus what? 4. Negative 2 minus 4. Negative 2 minus 4. And equal to negative what? 6. So this is the negative c that we have. That means our c is equal to negative 6. And therefore you bring it back to the function f of x equal to x squared. This is the function that I'm talking about. X squared plus 3x, and then the last one is what? Yes, the c is what? 2 plus c, and then our c is negative 6. And if our c is negative 6, that means our f of x equal to x squared plus 3x minus 6. So this is the final result. So basically, this is the specified points that were given for us to be able to find the solution of the antiderivative, the specific solution or the particular solution. So this is a particular solution of the derivative, that antiderivative that they were looking for based on the specific points or initial conditions given. So this is the result based on the initial condition. Without the initial condition, we should have had this result. But with the initial condition, now we have a specific result over here. So let's go further and see something. So basically, with this function over here, with this function x squared plus 3x minus 6, that means that it will be a minimum function. If it will be a minimum function over here, and it will be a minimum function for, let's say, y, x here, let's assume that the graph will be around this part. The graph will be around this part, but remember that because of the c, when we are using this one, x squared plus 3x plus c can be 1, c can be negative 1, C can be negative 2, C can be negative 3, C can be negative 6, C can be negative 7, it depends. So let's assume that we have something like negative 1, negative 2, negative 4, maybe negative 6, negative 8, right, and so forth. And then we have 1 as well. So if my function will have this thing like this, it will be something like this, right? Yeah, so this is how my functions will be, right? So this is actually the general solution. But because the initial conditions were given, we were able to find a specific solution. So, and because we have been able to find a specific solution, if our function will have this structure, then it will lie within this. Therefore, these ones will not be there anymore. These ones will not be there anymore, right? These ones will not be there anymore. These ones will not be there anymore. And then finally, you have your specific solution with this function. So that is the difference between the general solution and the specific or the particular solution for the function.